Hi, I'm Benny D, and in this video we're going to look at how to find the volume of spheres. Okay, so we need to think, what is a sphere? Okay, well, a sphere is notoriously tricky to draw in 3 dimensions, but I'll give it a go. Okay, a sphere is essentially just a bowl. Okay, it's just a bowl. So we like this curved surface coming around. Okay, it's just the shape of a bowl. Okay, we're looking at how we find the volume of a bowl. Okay, so the proof of the formula is a little bit tricky for me to do here in this short video. Okay, so you're going to need to trust me on this one about our formula. But our volume equals 4 divided by 3 pi r cubed. And we'll go through that a little bit. Okay, remember we need to have dimensions that are right angles all the time. And because it's a 3-dimensional shape, we need to have 3 dimensions involved in this. Okay? And those 3 dimensions are all wrapped up in this r to the power 3 term. So, just like a circle, where the radius starts at the center and goes out to the edge, and it's the same anywhere, for a sphere that's true in 3 dimensions too. So where this can go around in 2 dimensions, okay, a sphere curves over and it's 3 dimensions, okay, and the radius can stick straight up or at a bit of an angle to that surface. It's going to be the same all the time. Okay, so if you like, we get our 3 dimensions at right angles by having an R and an R here and here, and then we have another R coming straight up out of the page. Okay, straight up out of the page is our third R. Okay, so that's where our 3 R's come in, and we can think of them all as at right angles if you like. Okay, it's not surprising that pi is going to come in here because pi has lots of things to do with circles. And also, remember if you'd seen our work on our cone before, we'd had to divide it by 3. Okay, that dividing by 3 is still in there, but we also had this times by 4 business going on. So it's a little bit different, okay, a little bit different, okay, but it's not too hard to work out the volume of a sphere because you only actually need 1 dimension, which is the radius, and access to a calculator to make this work a bit easier. So I will probably rewrite this a little bit, okay, and say that we've got the volume equals 4 times pi. Now in pi we're going to use 3.14 times our radius cubed divided by 3. Okay, just going to make our calculations a little bit nicer at times. Okay, so we can go ahead and pick a value for r here, okay, and I'm going to keep it small to make it a little bit easier on myself and say that the radius is 2, okay, just 2 centimeters. So then our volume is going to be 4 times 3.14 times 2 to the power 3, or 2 cubed, divided by 3. And that means that we've got 4 times 3.14 times 2 times 2 times 2 divided by 3. I'm going to change the order that I'm going to multiply these a little bit. So I'm going to go 2 times 2 is 4. 4 times 2 is 8. Times 4 is 32. Times by 3.14 divided by 3. Okay. So the timesing by 3 and dividing by 3 are basically going to cancel each other out. So I only actually got to increase this just a little bit, and our volume is going to end up something around about 35 centimeters cubed. Okay, because we're going to increase it by this 0.14. So let's just estimate there's going to be around about 35. It'll actually be a bit higher than that. Actually, it'll be probably close to 36 or 37. Let's call it 36 centimeters cubed. Okay, remember, once you have set up your equation with what it looks like, this is all just calculator stuff. Once you've got your values in there, use a calculator, help yourself out. Okay, so it's a little bit of an extension, this one, with our other volumes that we've seen, but hopefully that'll be enough to help you out if you need to look at the volume of a sphere.